So this question looks like it's going to be a translate word problem question. I say that just given the sheer length of the question itself. And all that means from a strategy standpoint is that instead of reading the question from start to finish all in one go, I'm going to make sure to pause between sentences and make sure to write down any quantitative information as I see it. So let's look at this first sentence. So the first sentence here says, at a movie theater, there are a total of 350 customers, right? So I'm going to just write down 350 customers as what I get from the first sentence. The next sentence says each customer is located in either theater A, theater B, or theater C. Okay, so those 350 are split up into A, B, and C. If one of these customers is selected at random, the probability of selecting a customer who is located in theater A is 0.48. Okay, so if the probability, so now I'm going to use this information to help see, well, what else can I figure out? If the probability of selecting a customer at random and they happen to be in theater A is 0.48, well, that basically means that it's 48% of the customers are in theater A. If I know that I have 350 customers, I can actually figure out the exact number of customers in theater A by multiplying 0.48 times 350. I'm not going to solve that quite yet because I don't know if that's what we're looking for, but that is exactly what you would do to figure out the exact number of customers in theater A. It goes on to say, and the probability of selecting a customer who is located in theater B is 0.24. So the same exact concept. That means there are 24% of our customers are in theater B. And again, if I wanted to know exactly what that number of customers was in that theater, I can multiply 0.24 by 350. Next, it says, how many customers are located in theater C? Okay, so then a couple of ways to do this. First of all, if 0.48, and I'll use a different color here, if 0.48 or 48% are in theater A and 0.24 or 24% are in theater B, that means the remaining customers are all in theater C. Right, so when I add these two together, 12, add 1 there, 7, that means 72% of our customers are spread out between theater A and theater B, which means that 28% or 0.28 is the probability of selecting a customer in theater C. Now, I know that because we start off with 100, like this has to equal 1 altogether, and of course 1 is represented by 100%. Right, so if I looked at these as percentages, I can say, well, I have 48% in A and 24% in B, so altogether that's 72%. So how would I figure out how many are in C? Well, that's just 100% minus 72%, which is 28%. Okay, so then I could take that 0.28 and multiply by 350, and let's see what I get. So go to my calculator. 0.28 times 350 is equal to 98. So there are 98 customers in theater C, and choice D is the correct answer. Now, I could have done that a bit differently. I could have solved back when I wasn't solving these, I could have solved them, right? So for instance, I could have said, well, 0.48 times 350 is 168. So that's for A. And then 0.24 times 350 is 84. And then I can say, well, 168 plus 84 is 252. So 252 of the 350 customers are in theaters A and B, which means in order to figure out how many are in theater C, instead of doing it the percentage way, I could have said, well, I know there's a total of 350 total amongst all 3 theaters, and I know that there's 252 in theaters A and B. So if I subtract that, I find the difference between those numbers, then that gets me to the number that I expect to have in theater C, which is 98. Right? So that's 2 different ways to get to our answer of 98 here.